intelligent, and most of the ID designers have basically integrated the syntax analyzer in the ID itself. For example, if you use something like if you use NetBeans, okay, or if you use Visual Studio Code, all these things have the ID already integrated with syntax analyzer. So they are just helping you to check, like if you just type if, there will be a prompt here, and that prompt says that just press the space bar and you will get a skeleton of if. Okay. Sometimes you will also say that suppose I want to write for, then you will find yes, I want the compiler understand that the user is writing the for loop, and the compiler will say okay, I will help you for writing the for loop. Okay. But then as a student, you must understand what is the logic behind syntax analyzer. Okay. So logic behind syntax analyzer is called as parsing, right? You must have seen in Word also. If you type something in MS Word, apart from spell checking, you can also check the grammar of your sentence. Okay, and that is nothing but this check is through the activity called as parsing. Okay, so I can go in lot of details, but then due to the timing constraint and the amount of lectures allotted to me, I think we cannot go beyond certain limit of discussion. But then there are a lot of concepts going on in industry wherein you are designing some parsers for uh, so there is a parser called as part of speech tagging. Okay, so it will tag like which word in your English sentence is verb, or which word in your English sentence is noun, and so on. And then lot of good research is going on in the domain called as natural language processing. Okay, what we are processing is programming language, and hence we use the programming language parser. Okay, and if you process NLP, that is the language, suppose I'm speaking with you, it is a natural language, so then you can use something called as part of speech tagger. And there are a lot of tools. If you are further interested, you can uh, download this utility NLTK. If somebody is doing text processing, NLTK is one of the tool which you can integrate with Python and use it for NLP. Okay. So this is just the additional information for all of you if you are doing some projects or uh, some sort of assignment or something related to text processing. Okay, and it is a very interesting area. Uh, so when we talk about parsing, parsers are basically the tool which will scan your sentence. Okay, and it will say that okay, this sentence is correct according to the grammar. And there are two different types of parsers in your GATE syllabus. One is called as top-down parsing, and another is called as bottom-up parsing. Okay, so generally most of the compilers are based on bottom-up parsing. You will come to know why bottom-up parsing and how it is helpful, how it is speeding up the operation. So what I will do is I will just give you a brief idea about what is the concept of, first of all, what is the concept of grammar, okay, and then how grammar is helpful in representing language. So if I say grammar, grammar is represented by uh, the quadruple called as so V and then T and then This is V stands for non-terminal, T stands for terminal, okay, S stands for start symbol, and P stands for production rules. So non-terminals, then sometimes you can also write in place of V, you can write N also, okay. So N stands for non-terminals, T stands for terminal, S stands for start symbol, and P stands for production rule. So suppose I write S tends to I CSES. It means that it is a production rule where the symbol S can be expanded as I, C, S, E, and S. Okay. So this is just a simple production rule if condition statement else statement. And now you can expand condition to some relational operator A less than B and some statement and some statement. So this is called as parse tree. Okay. And for every string in your program, okay, for every string in your program, you can construct a parse tree. And if for a grammar and for a string, if you can construct multiple parse trees, okay, then the grammar is called as ambiguous grammar. Okay. So if the grammar is ambiguous, then for a given string, it will create multiple parse string. And that creates the problem because the syntax directed translation scheme or further processing of your string will be dependent on tree 1 and tree 2 both. Okay. So normally we do not prefer ambiguous grammar. We prefer generally unambiguous grammar, wherein for a string, for a grammar, there is single parse tree. Okay. So I hope you must have also studied all these things during your course on compiler in your curriculum. Okay. So we have good number of students today. 29 students have already joined. That's a big number for GATE. Okay. Almost touching 30 now. That is a good. Uh, so I am very happy to see that you all are interested in learning. Okay. And you want to understand some more detailed logics. Okay. Let me change the screen one more time. Let me add some more slides here. Okay. So let's proceed further. Just a minute, I'm sharing the screen for you. So I hope you understand what is the idea of grammar. Grammar is a way of representing language, and parsing is a mechanism to check whether the given string belongs to language. So through grammar, you will be able to prove that the string belongs to the language. Just like in English language, you write an apple and you don't write the apple or this apple. You always have a vowel rule. So these are all grammar rules for English language. Okay. So let me share another screen with you. Right. I think the screen is visible to all. Not just a minute. Yeah. So there are a lot of concepts like the concepts which we are planning to touch are like what is left recursion, okay, and what is left factoring, okay, then what is LL1 parser, okay, then what is LR parsers and their types, okay. For the we can also talk about some optimization. So for optimization, so LR parsers will have something like LR0, then followed by LR1. Maybe you can also take SLR, maybe you can take CLR. And then for optimization, you can make use of the parser called as LALR, which is look ahead LR parser. Okay. And most of the times, people are making use of LR parser because they are quite uh, accurate. They provide better speed, and as well as they also permit the concept of left recursion and left factoring. So there is no need to resolve recursion here, left recursion and left factoring, whereas LL1 is top-down parser, and it is basically generating the string, but it takes a lot of time to generate the string as compared to LR parser. Okay, so designing LR parser is more complex than LL1 parser, but once it is designed, then it is more efficient and more faster. Okay, and you can also do some optimization on LR parser, and that optimized LR parser is called as LALR. Okay, so just to check like whether some concepts on this are covered during your course in compiler at your institute, or should I touch all this? Can you just put something in the chat window related to these points? Anyone, like we have covered left recursion or left factoring or LL1 or finding first, finding follow. So if you can put something on this, it will be helpful for me to understand what you know. Otherwise, uh, I don't mind covering all these things because anyhow I should teach you all these things. So anyone from the class can tell me on the chat window that you are somewhat familiar with some concepts on something like this: first follow, left recursion, left factoring. Anybody? Or should I cover all these things?
Yes, sir.
Sorry, what should I cover everything on this?
Yes, sir. It is required. Somewhat, I know about LR parser and
Okay,
optimizer.
okay. But then other people, anybody from the group, uh, so it should not be a repetition of the topics which you know thoroughly, and probably because we don't have that big time available with us. So I don't mind, not an issue. Let us start with what is left recursion. So if you say, because you will always get a new concept, I know all these things very deeply. So let me take some ideas on this. Okay, so let us start with what is left recursion. Okay, so I think you all familiar with the language called as English, and I am very much sure that most of you also have studied Urdu as the language. Okay, so when you write English, look at the way I'm writing. I'm writing from this end to this end, and when you studied Urdu, you write from the right end and you go towards left end. Okay, so this is very interesting concept because in English you start from left to right, and in Urdu you start from what, right to left. Am I correct? I'm not very much familiar with Urdu, but I know that in Urdu you write from this side, right? So right to left, is it true?
Yes, sir.
Yes, yes, very correct. Yeah. So look at this language. Like both the language will help you to write your will help you to write your text and communicate. But in English, we start from L to R, and in Urdu we start from R2L. So logically speaking, your parser or your compiler should know these facts, and the parser will scan the string from L2R in English and R2L in Urdu. Okay, so that's why some languages do not permit left recursion, because you write the program in English language, okay, and if it permits left recursion, what will happen if it permits recursion? Recursion means growth, okay. Recursion का मतलब है grow करना. So if you are able to grow in right direction, this is your right direction, and you start from left, so then it is called as right recursion. Oh, okay. So this is allowed in English. But if your production rule is something like this, let us take one small production rule wherein you have something like A derives to capital A followed by small a, okay, and maybe small b, okay. So the problem with this production rule is when you draw the parse tree, this parse tree will be growing always in the contra direction, always in the left direction. You can see that it is growing in the left direction all the times. So this is not permissible in English. In English, your sentence must grow in right direction. And if the sentence is growing in right direction, parse tree should also grow in right direction. This is permissible in Urdu. Okay. So then this phenomena is called as left recursion. Okay. Are you getting why left recursion is not permitted in the language for which using which you write the program? Because your monitor screen grows from left direction to right direction. It cannot grow from right direction to left direction. You must have observed that you are not writing your text like this. Okay. Okay, so sorry for the interruption. So when we talk about recursion, the left recursion is not permitted. And now you can always remove the left recursion by adding a new production rule to the grammar. Okay. Very importantly, like you can always add a new production rule in the form of what? If I say like this only, A tends to capital A small a followed by B, then A tends to, I can always write A tends to. So logically it is something like this. If I expand or if I write it correctly from the literature, A tends to alpha followed by beta 1 and alpha followed by beta 2. Okay, if this is a rule, then this alpha is there, uh, which is creating the problem. Okay, this is left factoring, it's not left recursion because alpha is there. This is left recursion wherein you have we have written A tends to capital A small a followed by small b. Okay, so the problem exists where you have something like this: A tends to A alpha followed by beta. So if you have something like this is called as left recursion, and if you have something like this is called as left factoring. Both are not permitted. Let us try to understand how to resolve left recursion. We write A tends to beta followed by A dash. Okay. So this beta and new product rule, new terminal, non-terminal is added called as A dash, and A dash followed by alpha A dash and epsilon. Okay. So this is the grammar which is equivalent to the given grammar, because it will create the same parse tree. Only difference is in this case the tree will grow in the left direction, and in this case the tree will grow in the right direction. Okay, let me show you with this example which we have just discussed. So just a minute, I'm just removing this one and look at this. A tends to A, capital A, followed by small a. So what is alpha here? This is alpha. Okay. And what is beta? This is beta. So this rule will change to A tends to what? B followed by A dash. Okay. And A dash tends to what? A dash tends to what is alpha? A. So it will be A dash followed by epsilon. Okay. So now if you just take the tree, it will be A and then B and A dash. Okay. And now A dash can be replaced by epsilon. So once it replaced by epsilon, the tree will stop growing. Otherwise, it can be replaced by A dash. Okay. So you will find some difference in the two trees. One tree is growing in the left direction, which is not permitted in English, and one tree is growing in the right direction, which is permitted in English. Okay, so left to right is permissible, but right to left is not permissible. So that is basic idea of left recursion. Okay. Similarly, you have left factoring also, where the first symbol is used in at multiple rules. So let me show you one more example here. So you can try some examples, like if you have 8 and let me take one more example on left recursion. So A tends to capital AB followed by X followed by Y. So there is no problem in this rule. Only problem is this A. And then this becomes alpha, this becomes beta 1, this becomes beta 2. Okay. So now how will you write? You will write A tends to what is beta 1 X A dash or Y A dash. And next you can write A dash tends to what? AB A dash. Okay. Followed by epsilon. So the grammar which is here, this is G1 and this is G2. Both are same. Only difference is one will grow from right to left. So this is not permissible, and one will grow from left to right, which is permissible. Okay. Similarly, if you say left factoring, let me change the ink so that you will be able to get the difference. If I write A tends to, okay, alpha is there. So if I write A tends to something like this, let us take some rule wherein there is a problem of same common symbol. Okay. So same common symbol, A tends to CD. Okay. A tends to capital CX. Okay. And maybe capital CY. Okay. And so on. So what it does is it will take the rule will be modified as A tends to what? Alpha A dash. Okay. And A dash tends to beta 1 or beta 2. So then there is only one rule which starts with alpha. If there are multiple rules which starts with alpha, compiler gets confused which rule should be used. So how do we translate? Here we have something like this. Assume that there is one more symbol called as capital Z. So not an issue. This is beta 1, this is beta 2, this is beta 3, or sorry, this is beta 1, this is beta 2, beta 3, beta 4. So you can always write A tends to what? Capital C A dash. And now A dash can be replaced by D or X or Y or capital Z. So logically the grammar is same. Only difference is compiler now understand that there is only one rule which starts with C. But here there are multiple rules which starts with C. So that's the problem. So this is just about left recursion and left factoring. Okay. And the problem of left recursion and left factoring is more prominently uh, should be resolved if you are talking about LL1 parser, wherein the start symbol is reduced to string. Okay. This is called as top-down parsing. And if you are converting the string to the start symbol, then it is called as bottom-up parsing. The basic difference in these two is one will start from the bottom of the bottom location and one will start from the top location. So if you are starting with root, then it is called as top-down parsing. And if you're starting with the lowest path, then it is called as bottom-up parsing. Okay. So let us move further. So given a grammar, let me change this thing now. Yes. Now let us try to understand the significance of the concept of first and follow. So please understand it carefully because it will be there in all the parsers. Okay. So all the parsers may use the first and follow information. Now let me show you why we calculate, why or what is the reason we compute first and follow. So let us start with this. Suppose I have a rule S tends to small a and capital A, okay? And maybe let me take some grammar for the reference, okay? And then we can compute this first and follow, okay? Yeah, let us take this one. S tends to small a, capital A, okay? And S tends to something like small b and capital B. And then A tends to X and B tends to Y. Okay. So now, if I say that using this grammar, please answer on the chat window, generate the string, okay, which is something like this, CXY. Can you generate the string using the above grammar? Yes or no? On the chat.
No, sir.
So write the answers on the chat window. Can you generate the string uh, CXY using the given grammar? Everybody should contribute, should write. Okay, very good. Now I'm getting the answers. Most of you, three people have answered. Yes, keep on answering. This is good. See, because now when you will be facing the campus interviews, you will be facing it in the same order. They will ask you to write on the chat, speak through the mic, and so on. Okay. So please make a habit of answering the questions. Why you say that? Because you don't see that any production rule in the grammar has starting symbol as what? C. So this is basic idea of first. Okay. What first helps in? So you can always find that if you have a start symbol as, and in the first set of S, which is called as first of S, you find some symbols like A and B, then your compiler understands that every string which you are deriving will be only starting with either A or B. You will not be having any other string than AB. Okay. So why C is not possible? Because so you can always have something like this, A and X, and you can always generate A and Y, because you can replace this A by X and you can replace B by Y. So who is giving you the idea of replacement? Again, what is first of A? It is X. What is first of B? It is Y. And these production rules will help you to understand that if you are replacing A, you can replace it with X. So always remember that non-terminals will be replaced by terminals. And when you draw the parse tree, then your parse tree will have internal nodes as non-terminal, and your parse tree has leaf nodes as terminals. Okay. So you will never see something like this as derives to X and capital A. It is not, cannot be a leaf node. This A has to be replaced by some A or B or so on. Okay. So remember that whenever you are constructing the parse tree will have the symbols. Internal nodes will be either non-terminal or terminal, but always the leaf nodes will be terminal. Okay, correct? Right. So, so why do we find first and follow? I think I have cleared what is the logic of first. Okay. So if I say S derives to again something like this small a b, okay, and A derives to something like Z, and maybe B derives to something like X. So your string can be AZX, okay, because you can always replace A with Z and B with X, okay. Right. Now, another concept in the parser design is follow. So, why do we need follow? Follow is basically uh, the idea which helps you to grow. Okay. For example, if I say what is after A, so after A is what? B. Okay. So if I want to find what is follow of A, okay, then I must know what is after A. And if follow of A needs to be calculated, it will be calculated using the rule first of something. And that something is nothing but it is the symbol which is present after A. Okay. So uh, so this is about first and follow. Would you like me to take some example on this, or should we go ahead to parsers? You know this computations, and you are aware about how to calculate first and follow. Kindly respond on the chat. So I give you the idea why first and why follow. First will give you the impression that which are the permissible symbols, uh, which are the permissible symbols, which helps you to uh, finally derive the string. And follow will be helping you to basically travel. Himanshu is saying that examples will be better. Okay. Any opinion from other students? Or Himanshu is giving a representative answer. Any suggestion from the other students? What would you like? Okay, okay. So let me share you. I'm just sharing you some example screens. Okay, just a minute. That's good. You give me the feedback because see, we cannot simply learn everything in the time allotted, but whatever we will learn, it will be definitely very useful for all of you. Okay, so let me share some screen, another screen with you where I have the first and follow computed. Just a minute, right? Okay, so 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 now probably you will be able to see some screen wherein you can see some examples. Okay, and So I told you why we compute first and follow. So if you want to find out like which, so normally in English, the pronouns are basically first, and then the string is derived from the pronoun. So you normally start the string with the words like this, that, the, a, and so on. So this is a grammar given wherein you can see that in some of the production rule. I think the screen is visible. Word document is visible to all. Okay, good.
Yes,
Thanks.
sir.
Yeah. So now you can see that some sort of grammar is there, and there is a parsing table is to be constructed. I'm not touching the gate examples right now, but in the next 5 minutes, I'll finish off this, and then we can come to the gate questions. Okay. So here we have some grammar. You can see that there is a left recursion here. Okay. And that left recursion is being removed using the left recursion rule. If you see this as B alpha followed by beta. So this is beta b dash and alpha b dash followed by epsilon. Okay. So now you got a new grammar wherein there is no left recursion. And now we are trying to find the first. So this is a very simple idea. When you are finding the first, you need to check this is called as left hand side and this is called as right hand side. Quickly, I am showing you some tricks wherein you can fast calculate first and follow. So if I say S derives to A, B, D, H, if there is a terminal symbol, then there is no problem. So just remember these small rules, because in the gate you need to solve this all in very quick time. So you cannot basically compute on the paper pen. So if there is a terminal, you stop computing first. So S derives to ABDH. So first of S will be first of ABDH, and that is equal to A. Now you continue finding first in the same order till you find some problem, like where you have a rule wherein the rule starts with non-terminal. Okay. So if the rule starts with non-terminal, it will expand. If the rule start with terminal symbol, then probably wherever there are non-terminal, expansion will happen. Otherwise, expansion will not happen. Just like in this rule, B tends to CB dash. So you can always say first of B is first of CB. Okay. This is your right hand side. इसका फर्स्ट इसको दिया जाएगा. Okay. So first of B is first of CB dash, and you can always say CB dash first is C. Similarly, B dash is no problem, followed by epsilon, no problem, you continue. Now the important part is here. This is the important part. First of D is nothing but first of EF, and now you calculate first of E. So the problem is, as soon as you find a epsilon, epsilon is null character, and if it is there in first, it will create a problem because it will not allow you to move further. Okay. So first of EF is equal to first of E, and first of E is G epsilon. Okay. Right. So since it is G followed by epsilon, you need to resolve epsilon. Why you need to resolve epsilon? Because no string will be starting with epsilon. Just remember this. You must have written English strings, and you must have observed that every time you never start the string with a space bar. Okay. Whereas epsilon on keyboard is a space bar. Okay. And you never start your string with epsilon, hence you never have epsilon in the first set. Okay. So it's very simple. If you find epsilon, then you resolve it by a rule that says first of D is first of EF, and if first of EF will be what? First of E, and first of E is G epsilon, and since it contains epsilon, you will say, okay, I will resolve it by moving further. Okay. And how do I resolve it by moving further? I will be taking first of E minus epsilon union first of F. Okay. So somebody may say that what will happen if F is not there? Okay. So I will come to that point also. What will happen if F is not there? Then in that case, this is called as unit production. Okay. D tends to E. So such production rules needs to be resolved before you construct the parser for such grammars. Okay. So finally you can always resolve unit productions by replacing the right hand side by its production rules. Okay. So all these things are there in TOC course also. I assume that you must have studied how to reduce the given grammar. Okay. Now, if you say first of EF, you can write it as first of E minus epsilon union first of F. This is the rule for resolving the epsilon. Okay. So if you want to resolve the epsilon, you write it as first of EF equal to first of E minus epsilon union F. What is first of F? Again, first of F is consisting of what? This first of F is nothing but F epsilon. So again, you find epsilon there. Now we try to compute first of D. First of D is nothing but first of EF, and that is nothing but G epsilon minus epsilon union what? First of what? F. That is F epsilon. So you have F, G, F, and epsilon. So you can see that we have in the D we have GF epsilon. So never you will never see that in the first information for a non-terminal only epsilon is there. That is not permissible. Okay, but epsilon is permissible if it is having another symbol with it. Okay, so if first of what is first of E? First of E is nothing but G epsilon. First of F is nothing but F epsilon. Okay, so this way you can calculate first very easily. You must remember this rule. If any particular uh, non-terminal symbol derives to epsilon, and if it is having extension that is, for example, let me write it here. Suppose you write S, uh, suppose you write capital S derives to what? XYZ, capital XYZ. Okay. So if you, what you will compute? You will compute first, you will compute what? You will compute first of S is equal to first of what? XYZ. Okay. And since you're computing first of XYZ, it will be equal to what? It will be equal to first of, yes, what? X. If this first of X contains epsilon, you apply the rule first of X equal to first of X minus, if I'm writing this here, I'll just copy this epsilon from this place and put it here. First of X minus epsilon union what? Union, so this is union symbol, first of YZ. Now you need to compute first of YZ. Okay, and that is equal to first of Y. Okay, if it still contains epsilon, then you will compute first of Y equal to what? So this is very strongly continued till you are able to continue. Okay, so it is first of, okay, what? First of Y again minus epsilon union what? First of Z. When you will stop, you will stop uh, when you cannot continue. So now if the epsilon is there, you will allow that epsilon to remain present in the first set. So sometimes this is permissible, but it has to be supported by certain symbols. Okay. So there can be some rule wherein you have something like this. Okay. So you will find in LR, we can use certain rules. A derives to, okay, epsilon, then first of A will be simply epsilon. So such rules have no meaning because they will not be used in the expansion, rather than they will be used in the termination. Do you know, can you tell where such rules are applicable, A derives to epsilon in English? So what is the termination symbol of C language, C instruction? How do you terminate the C instruction? Which symbol you use? Yeah, anybody? Very good, Dheeraj. What is that? Semicolon, right? Uh, so what is the punctuation symbol to terminate the English sentence? Very good. Dot. So this is A derives to epsilon is nothing but that A derives to dot. Right? Very good. Good answers. Keep on answering. So A derives to dot. So logically, these rules are nothing but they will be further expanded as A derives to dot. Why we need such rules? Because we want to terminate our string with a punctuation symbol called as full stop. Okay, good. So this is about first, and similarly, we can also have the follow. So always remember that you will be finding the first set for the left hand side non-terminals. Okay, and when you are talking about follow, you will find the follow for right hand side non-terminals. Why we do like this? Because left hand side will be helping you to start the string production, and right hand side will help you to grow with your requirement such that your grammar terminates with the string. Okay, so right hand side is basically the rule base, and left hand side is nothing but it is the start point. Okay, so for which symbols of left hand right hand side you will find the follow, you will only find the follow for the non-terminals. You will not find the follow for the terminal symbols because they will be terminating symbols. So their follow will not be used. Okay. So what is the first symbol on the right hand side in the rule? A derives to A, B, D, H. It is B. So you will find the follow using the rule called as follow of B is equal to first of DH. Okay. So there is a follow rule here, which if you want, I can write for you on the board. And then also if I can share these examples with you also, and you can always refer these examples. They are quite interesting, as well as they cover a lot of concepts on first and follow. Okay, so I'll be sharing it with you. So when you are computing follow, you will compute follow with the, suppose there is a rule S derives to alpha A and B, then you compute follow of A equal to first of B. Okay. And if first of B contains epsilon, then you continue with the first rule. Okay. And even there is no first, then you continue with the follow rule. So uh, let me just explain this because it is a good concept and you can remember it easily. Okay, let me come to the slideshow. I think I'm not able to write on this. Okay, yeah, I can write now. So if I have some production S derives to uh, oh no, it's not allowing me to write with the keyboard. Just a minute. Not possible. Okay, let me come to the presentation slide so that I can write there for you. Just a minute, I will open this. Yes, yes. So when you are computing the first, I think the screen is visible. So when you are computing the first, you need to compute the first for the R first for, always for. So this is the rule. Let me remove S also. This is the rule. LHS derives to RHS. So when you are computing first, you compute it for LHS. And when you are computing for follow, it is an expansion rule. So you will compute it for RHS, but you will only compute it for non-terminals. So if there is a rule S derives to small a, capital B, D, H, then you will not be interested in computing follow of A, but you will be simply interested in computing follow of B, which is equal to first of whatever is there after B. Okay, right? And first of DH will be calculated using the regular first rule, that is equal to first of D. Okay, इसमें अगर एप्सिलॉन है तो इस फिर से आप फर्स्ट ऑफ डी कैलकुलेट करेंगे. फर्स्ट ऑफ डी इक्वल टू फर्स्ट ऑफ डी माइनस एप्सिलॉन यूनियन फर्स्ट ऑफ एच. ओके, right? So always remember that first rule will be more largely used than the follow rule. Okay, but if you find what do you find that after computing everything, if the follow, if the first of even after computing first of dh is still containing epsilon, then you will write follow of what, b equal to what, follow of b equal to first of dh minus epsilon union follow of s, which is your start symbol. And by default, follow of s is basically equal to dollar. So since it's a start symbol, इसका follow हमेशा dollar रहता है. We will see in the parsing table some of the concepts. Okay. So I think we're done with the time, but then let me share some of the gate examples also with you. Yesterday we discussed some of the examples. We can take few more examples today. Yes, let me share that slide with you. Okay. So these are few gate examples from the old question paper. Which of the following derivation does the top-down parser uses while parsing an input string? Okay. The input is assumed to be scanned in left to right order. So this is what we just discussed, that the parser will always scan your input string from left side to right side. Okay. And what this question says, that which of the following derivation का मतलब है कि expansion rule. Okay. So which derivation will be used? Put your responses on the chat window. Leftmost derivation रहेगा, rightmost तो नहीं use होता English में. तो क्या use होता है English में? It is always leftmost derivation. Okay, because you are using the English language for writing your programs. Okay. Another is, so given the following expression, which of this is true? Whether, so normally in the precedence rule, you observe that asterisk is having more precedence than plus and minus. Okay. So for such examples, what you need to do is to draw the parse tree. Very simple. So let me show you the parse tree. You can draw the parse tree like this. E derives to E star F. Okay. And what is F derives to? F derives to F minus F. Okay. And what is E derives to? E derives to F. Okay. So maybe you can see here that when you start from start the evaluation, this star will come later. Always the evaluation will be from bottom up manner. So this F minus F will be first evaluated. Hence, minus will have higher precedence than asterisk. This you remember. So sometimes you may find this in bracket. Bracket will be having the highest precedence. Okay. This is one more. Which of the following statements is false? An unambiguous grammar has same left and rightmost derivation. Okay. Unambiguous grammar का मतलब है कि it is generating a different parse tree for different string. Okay. Ambiguous का मतलब है कि there will be two parse tree for the same string, and unambiguous का मतलब है कि there will be only one parse tree for the string. So on, if there is only one parse tree, then definitely uh, you need to think about a simple answer in this case, where when you have something like true false. Okay, and LL1 parser is top down, so LL1 parser is yes, top down, it's not false. LALR is more powerful than SLR, yes, because it's an optimized parser. An ambiguous grammar can never be LRK for any value of k. Yes. So this is also not false. What is false is ambiguous grammar has same leftmost and rightmost derivation. That is false. It cannot have same leftmost and rightmost derivation because it is unambiguous. Ambiguous grammar will have same leftmost and rightmost derivation. Okay. Which of the following suffice to convert a arbitrary CFG to LL1 grammar? Okay. So CFG is nothing but context-free grammar. Okay. Context-free grammar is basically context free grammar का मतलब है कि you will always have the structure like English language, context free. Okay, so in that case you should not permit what? You should not permit left recursion and left factoring. So if you want to convert the context-free grammar to LL1, then first of all remove the left recursion and left factoring. Okay. Uh, SLR and other things we will cover. So these are the five questions which were there from the current discussion. I hope this was useful to all. I will be sharing my Word document to the professor who is sharing you the link. So in that Word document, there are two examples on finding the first and follow, which you can use and understand the further logic. I will suggest you to read all that and come prepared in the tomorrow's class. Okay. So thank you very much. It is very good to see you all joining the class and uh, giving the feedbacks. Maybe you can also interact in between. I can still take few questions if you have anything to discuss. Otherwise, you can leave the meeting. Thank you very much. So the major takeaway of today's lecture was why we calculate first and follow. Okay. And how we calculate is a very simple idea, but why we calculate is more important.
Sir,
Yeah, 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 Himanshu, please.
sir, actually, I have been accidentally removed from the WhatsApp group. So, can you add my number?
Sure, sure. I will inform the professor to add your number. Okay.
Sir, where should I give my number? So,
You can write it in the chat. I will inform them. Not an issue. Okay.
okay, sir.
Yeah.
Yes, don't worry, Himanshu. Just meet Najish madam regarding it, and then she will be adding your number. Okay.
Uh, w- uh, sir,
Okay.
pardon.
We'll talk in college, right?
Okay, sir.
Okay. Thank you so much, sir.
Thank you very much.
Thank you, sir.
Thank you.